What is the boundary of consciousness? So according to IIT, the boundary of consciousness is subset of the mechanisms that maximizes system level integrated information. Okay? So that's a sort of the short answer. Let's come back to this network that we discussed in the last video. This is so the question is, which subset of this ABCD maximizes integrated information? You may have already an idea, and if so, then just say that right now, and then let's see how we can kind of identify it operationally. And this subset that maximizes integrated information is called complex in IIT. Okay, and the most integrated local maximum is the complex. So the local is quite important here, as I explained in the next video. And then what is the complex of this network? So that's the question. Let's try to think all possibilities one by one. Okay, and then first, let's start with a one unit situation, whether that's a maximum subset, locally maximum subset or not. We think about it. And then here the rule is that everything outside of the consideration of the boundary is its environment. It's outside of its existence. So to think about this, ABCD, apply this concept, ABCD, then A, if I think about it as a sort of the unit of its own, then A is something that is acting on the environment into B and C, and from acted by the environment from B and C. And that's all what A is kind of seeing or doing. And the same goes for B, and the same goes for C, same goes for D. Okay, and each of them, we need to think about it. Let's start with this D situation first. What is this D in itself? D itself has an on and off, kind of state, and D acts on the environment of C. Okay, and then, but that's it. And there's not much inside of D. And also there's not much D is influenced by anything, right? So it's almost like things that affects on something, but doesn't do anything. And in a sense, you can consider it as a like a TMS pulse, like the one that we talked about last week in a TMS EEG. It can, give a pulse to the brain to make a difference, but in itself, it's just, isolated kind of entity. There's nothing in it. So this means that no intrinsic existence of the D. And then, each of these isolated things, even the A or B or C, on its own, there's not much inside of it. So we don't need to really consider this as a sort of the integrated information, concept, complex. Okay. Now we are going to start to think about something more complex. And let's talk about the two unit candidates. ABCD can be separated into, AB versus CD, right? Also AC and also BD. That's also, potential two unit candidates. And also AD and also BC. So these are the all possible six candidates that is composed of the two units in this network. Among these, AD and BD are already out. Do you understand why this is the case? It's because A and D, for example, doesn't have any connection in itself. So if we disconnect the system AD into A and D, there's nothing changes, right? Same goes for the BD. B and D are not connected. So if B and D is noise, then nothing changes. And here, environment doesn't matter, with or without environment, because in itself, it's not, connected or whatever, noising doesn't make any difference. So AD and BD are definitely not the complex. Same goes for CD. CD is, separated between C and D, and then that's a unidirectional cut. And, if you cut it that way, C itself will be affected, right? Because now we don't know what the D is. And then that makes the difference in terms of how the C will behave and so on. But D itself is never changing, after the cut between the C and D. And therefore, this one has also very small, if anything, integrated information. That leaves us these three candidates of A, B, and AC, and BC. And notice that each of the three cases, there is a bidirectional connection between AB and AC and BC, and that's lost when you cut the connections with replace that with the noise. Now we go to even further complex things, which is called consisted of the 3-unit candidates. By removing A, we have BCD. Removing B, we have ACD. Removing C, ABD. Removing D, ABC. Okay. And then among this, let's first start with ABD. ABD doesn't exist again, right? Because B and D doesn't have any connection. So if we cut there, then there's nothing we lose. So here, integrated information of ABD is 0. So that's out. And then thinking about this BCD and ACD, BCD is also 0 because not 0, but the CD connection is very weak, and the ACD is also very weak in terms of CD connection. And so if we cut there, in both cases, we don't lose much. And so these are likely to be very low in terms of the integrated information. So when connections from D to C is cut, the system as a whole doesn't change much. And so it's basically the same level of integrated information as in C and D on its own 2-unit system. And then the remaining candidate of the 3-unit system is this ABC. Okay, and then we'll come back to this later. Similarly, now we think about this entire system, ABCD. And this leads to some confusion in some people. The more you think, you feel like you integrate more and your information gets more. That's not the case in the case of the integrated information. The more you have and the more weak connection there is, then it can become really weak. So here is a case. When a connection of CD is now included, we can cut it there. And in the end, what we found is that it's again the same level of integrated information like CD on its own because of this unidirectional cuts. So in the end, what we are left with is 3 candidates from 2 units and 1 candidate from 3 units. And in this case, most likely ABC is highly likely to be the complex. It has, no matter how you cut it, within AB or AC or BC, we lose a lot. We at least need to cut the 2 of the bidirectional connections. And that is more than the AB or AC or BC 2-unit system because there is only one thing to be cut. But it's more involved to precisely compute this because it depends on various factors such as connection strengths or state of the unit or rules of the state change. But as far as I said, like the units have only on-off states, and the connection strength is a copy, and rules of the state change is very simple, like copy. Then we need to go through that according to particular IIT formulation. But it's likely that the ABC is usually the complex. Okay, so now coming back again to this integrated information from actions post-rate. This consideration about complex relates to the actions of exclusion. Consciousness is definite in content and spatial temporal grain. Each experience has a set of phenomenal distinctions it has, neither less a subset nor more superset. And it flows at the speed it flows, neither faster or slower. And to support exclusion of conscious experience, IIT suggests that there must be a physical system that is bounded. And that corresponds to finding of the subsystem that maximize that is maximum in terms of its integrated information. So in summary, in this part, according to IIT, the boundary of consciousness is defined as a subset of mechanisms that maximizes system-level integrated information. And for the latest version of IIT 3.0, that is much more sophisticated but more math-heavy. You can take a look at this thing tutorial. So this is a YouTube link that we recorded on last year to explain IIT 3.0, and it goes from concepts to the really simple ideas, and then how it applies to each of these type of situation, and then in terms of IIT formalism using probability theory and intervention and so on, and then eventually we explain different, complicated situation, how we can actually compute this, over the using the exact formalism of the IIT. Okay. After understanding this, the question is, can we explain consciousness with this concept? And that's the part I'm going to talk about it next.